series. This is Lenny Goodell. I'll be presenting on building an EdgeX application service. A little bit about myself. I am a senior software engineer at Intel Corporation, been with Intel going on 23 years as my second career. Before that, I worked with Texas Instruments for many years. I've been working with EdgeX Foundry for about 3.5 years now. I am a member of the technical steering committee for EdgeX. I chair the applications working group. I am also the product manager for EdgeX. So this is just showing off what we have for this Tech Talk series. So Jim White presented last week the Getting Started with EdgeX, which is up on our YouTube channel now. So if you didn't get a chance to watch that, you can go see the recording. And then today's talk, and then next week we'll have Ian Anderson talking about building a device service. And then I'm not sure the presenters of the last two, but building a device profile. And then someone from Canonical will be doing how to get started with snaps. So the agenda today, at a high level, define what an EdgeX application service is, which is really centered around the functions pipelines. We'll talk about that. And then we'll talk about the couple types of application services you can have in EdgeX. So we have a configurable, and then you can build a custom one. And then we'll talk about the tools you will need to build your custom application service and how to jumpstart the creation of your application service using the app service template. And then we'll talk about how, once you've got your initial service created, how you customize it for what you need. And then we'll go into some techniques on how to test your application service. And then we'll follow up with some resources, and then if we have time for some Q&A. So if you're somewhat familiar with EdgeX, here's our standard diagram with what we define. South is the devices down on the bottom, and north is application services, and beyond that, your IT and cloud. So we're talking about this most north part of EdgeX, what we call the application services. So it's receiving data from the lower levels, processing it, and doing something with it. So what is an application service specifically? So it is a service, an EdgeX-based service. So it's built with EdgeX SDK so that it has the configuration and security if you're running in secure mode to connect to the EdgeX message bus. And it receives data from an EdgeX source, which is typically the EdgeX message bus, in order to transform that data, augment the data, export it outside of EdgeX to the cloud, perform analysis on the data, perform an action based on maybe that analysis back to a device, or can even publish new augmented or transformed data back to the message bus for other consumers. We have an LLRP application service which does this. It takes raw RFID events from the device service, transforms those into inventory move and arrived events and departed events, and pushes those back onto the message bus for other consumers. But it's open. You're receiving data from multiple sensors, and you can do whatever your use case needs. There are two types of application services. One being the configurable. So this is a pre-built application service that defines the functions pipelines in configuration. So there's no coding involved. You just need to configure the pipeline within the configuration and run the service. We have some built-in canned profiles for things like doing exports to MQTT or to HTTP to make it faster for you to bring up a service that's, if all you need to do is export and you just tweak the configuration in that profile. Then we have custom. Okay, so these are built using our application SDK written in Go. These are for when you just can't do what you need to do with, with the configurable. Okay, so application services are built around the idea of a functions pipeline. So pipeline functions are small pieces of work that process the data and then pass it to the next function. So in this diagram, you see function, the message bus trigger passes the data to function A first, and then does some processing transformation, passes the function B, and so on. And then at the end of the pipeline, it can then pass the data back to the response for the trigger, which in this scenario is the message bus. But it doesn't have to. Publishing back to the message bus is optional. It could just end with a function that maybe be an export. And so you're exporting it out of EdgeX, so there's no reason to publish it back to the message bus. Okay. And you can see that we can have multiple function pipelines. And that is in the case when we have a message bus trigger, because we can then set them and trigger them based on a topic. So the device name is in the topic when we receive EdgeX events, and so we could have a topic and a pipeline that is processing from device A and a separate pipeline that's processing data from device B. All right, a little bit more on app service configurable, but as I highlight here, this is not the focus of our talk today. Just want to make sure everybody's aware there is an option to writing a custom application service. As I said, it's pre-built and controlled via configuration. It is built using the same application SDK, but it allows you to dynamically configure functions pipelines via the writable pipeline configuration section in the TOML file. So all our configuration in EdgeX are in TOML format. It's restricted to using built-in functions that are already provided by the SDK. So there's the limitation. If you have some specific function that you want to run in your pipeline, there's no plug-in ability. So you have to write a custom application service. Provides, like I was mentioning before, some canned profiles. For the two most important ones are the exports to the different protocols. Lots of more documentation here that you can, if you're interested in this, you can go explore. Then there's a custom app service, which we're focusing on today. Again, you build it using the application functions SDK, written in Go. Use it for when the built-in functions don't meet your needs. You need to create your new custom pipeline functions. You can still use built-in functions in conjunction with your custom functions, which is typical, because there's lots of functionality already in the SDK that you want to take advantage of, but you may need to do a specific transform before you do an export. So you would need to write a custom application service to use that custom transform function, but then you would use the existing export function to get your data out to wherever you want it. Lots of documentation on all the capabilities that the SDK provides here at this link. Tools you'll need when you're developing your custom application service are Go. So if you're developing for the latest release, Kamakura, that's based on Go 1.17, and Jakarta is based on Go 1.16. They're all backwards compatible services, so you could still develop your new custom application service with Go 1.17 and the Kamakura SDK, it will work with Jakarta. As long as the major versions match, they're backwards compatible. So 2.2 built app service will run with 2.1 EdgeX. You will need an IDE or editor of choice because you're going to be writing code. You'll want the Git CLI so you can clone the application functions SDK to extract the template. You will need make because you're going to be building your executable. You'll want a terminal, bash or shell to run the git or make commands in, and Docker. Mainly, we want to be able to run EdgeX in Docker so we can test our new application service against EdgeX running. ZMQ library needs to be installed on Linux. If you're building on native Windows, you don't need it. We've been able to build in build flags, so it's not needed. ZMQ was the original message bus protocol that we developed around, which we're moving away from it. It's been deprecated. So when we do go to EdgeX 3.x, ZMQ will be removed. We're in Levski, we are adding in build flags so you can build without ZMQ on Linux, but those aren't there yet. Okay, so to jumpstart using the application service template, these are the commands you need to run in your terminal, which I'm going to go demonstrate right now. So to get hold of the template, the easiest way is to clone it. So my IDE of choice is JetBrains Golang. So I've created a workspace here for the Tech Talk, and I am going to go ahead and clone the app SDK. And this is just purely to copy out the template, okay? Then I want to CD into that folder. And I want to check out the label for Kamakura. There's no branch for Kamakura since we don't branch unless we need to make updates. So right now, we just released it. So there is, what is it doing? Oh, okay, that was right. That was right. It gives you this. When you do labels, it gives you this interesting message. Okay, so then I'm going to CD into the app service template folder. And then I'm going to copy it to a folder of choice. So just copy R, and I have created a temporary repo for the Tech Talk app, Tech Talk, okay? And now I want to go back to that repo. All right, so now I have the template, the start of my custom application service here. So let's jump back to the slides. Wrong. Where did they go? There they are. And of course, it's not in. There we go. Okay, so I've done all these steps. So in the template, there's a README that walks you through the steps to get your initial custom application up and running. And that we can do, we can read that README right here. Okay, one of the first things you want to do, we've already done the copy, is we want to change the name. So what we're going to do is we're going to go into the GoMod file and give it the name of my actual application. So I went ahead and set up a public repo in my GitHub for this application. And so I want to give it that. And then the next thing you want to do in this, because we build this template and try and keep it up to date as part of the SDK, we want to do the remove of the replace. So if you're familiar with Go, this is how you you replace the usage of a module with a local version. Maybe you've made some modifications, you want to test it. So in the template, so that uses the most current part of the SDK, we use this replace ... to get to the SDK above it. So you want to replace that. And that gets you to the next step is you want to do a global replace of the name to your name, which is mine is Tech Talk here. So I'm going to replace all those. If I didn't do global. Sorry, I need to do there it is. Now I'll get everything switched over. So now I've got my application is mine. Then the only place we have to adjust the import statements is right here in the main, because that's only specific places. We come in here and change that so that it's got the full URL, since that's got to match what the name I put in my GoMod file, the first part of that. So that's referencing to the config and functions package names that are local. All right. And then actually I'm going to skip the make test. I'm going to go to make build to verify now. Oops. I can build. So I do a make build here. So the make tidy makes sure that the GoMod file, well, the GoMod tidy that's part of the make build, make sure the GoMod and the GoSum are in sync properly for the dependencies in the GoMod file before we actually do the build. Okay, so our service built. All right. Going back to the README for the next step here. And then if you're wanting to build a Docker image, you can go into the Docker file here and make sure the names are correct. And since I did a search and replace, actually it's in the make file, sorry. The make file, so when you do make Docker, it's going to do this and create your Docker image. And for this example, the names, when I did the search and replace, are sufficient. All right. Going back to the README, now we can do a make test. Just to run the sample unit tests that I have in this template. And this takes a minute to get going. All right, so the test ran, and then as part of our standard EdgeX make files, we run go vet on the code. I'll show you that. And then we run go format to make sure the code is formatted properly. And then we have the script that makes sure the attribution file is up to date with all the dependencies. These are things you can remove or keep, okay? If you don't need an attribution file, remove the script, remove the attribution file here. Okay, this just shows the licenses for all the dependencies. Something if you're going to deliver this as another open source offering, you may want to keep. And that's running that script, which I know it's up to date. I'm just going to Control C that. So once this is done, a couple files have been created, a coverage out and our binary. If I'm going to commit this to these two, this project back into GitHub, I don't want those committed. So I'm going to go into Git and ignore those. So this is going to create a git ignore file and ignore the binary and the coverage file. So that's important to do. So you don't, you're not pushing binaries and unneeded files into your GitHub. All right, so back to the README. So the last thing in the README is it says you need to then go through the code and address all the to-dos that we've put in this template to walk you through finishing up that. But what I want to do is I want to drop back to my presentation and go to the next slide. There we go. So I put the 3 big things you need to do to customize your application service from this point. One is to decide what type of custom configuration you need. Okay. Most services going to need some additional configuration beyond what EdgeX provides. So we have 2 ways of doing this, which the old way was there's a canned string map called application settings. It allows you to give it a key and a string value. Okay, everything's a string. Okay, so if you're using that and you're putting a number in as for the string and you need to use it as a number, you have to parse it into an integer or a float or whatever once you've pulled it out of the application settings. The newer we have is what we call structured custom configuration, which allows you to have typed values and structure to it. Okay, so the application settings is just a list of key value pairs, where the structured custom configuration looks just like all the structure that's in the TOML file that the SDK provides. So we're going to take a look at that. And so on all the EdgeX services, you have a res folder and your configuration TOML file. So if you haven't seen this before, this is what you're going to see for the configuration. So we always have a writable and we always have log level. So writable means if you have the configuration provider, AKA console enabled, and it pushes your configuration in there, you can change anything in the writable section and the service will get notified. And all this section is supported by the SDK. So the changes are processed by the SDK. The service section is processed by the SDK. All of these sections, okay, are processed by the SDK. Okay. And we get down into here, we'll be playing around with the trigger. This is how you decide how your application service gets its data from EdgeX. And the standard type is EdgeX message bus, but we have some other types for you if you want to do other things. And then the EdgeX message bus has multiple implementations. Redis is the default, but you can do MQTT. That's why we have a commented out section here. So if you decide you want to use MQTT, you can get rid of this section for Redis and just uncomment this section for MQTT. Okay, to the custom application settings section. So as you can see, this is a key name and a long string. We have some helper functions. So if you want to have a comma separated list of strings, it can be easily parsed out. And then we have what we call our structured custom. Okay, you can see here, it has structure to it because it's got a layer, a second layer here, and it's got typed. So you can have numbers, it's going to be whatever this type in the structure it gets parsed into is. And then you can also have Booleans. Okay, so it's, as you can see, it's more like what we have for the SDK, not just key value pairs of strings. The name app custom is just a sample name. You can name it whatever you want. And you'll see in the code where you load it, you let the SDK know what section it's loading. We'll jump to that now. So in the main, this service has a wrapper, my app structure. You can unwrap this and keep it simple with just the main and all the stuff we put in run, create and run, or you can expand upon this and give this a more proper name for your use case. But what I'm doing here, walking down here, you can see here we're getting app settings, strings. So get app setting strings expects this key to be there, and it's going to process it as a comma separated list of strings. It's going to give you back that. So if we look at this, will it hover properly? I probably won't, but let's see. Not getting IntelliSense here like I want, but this returns a slice of strings. But then now we're going to look at the more advanced custom configuration, which is this. Okay, so you define a structure, a container that has the variable of the name that you're going to have in TOML. So you saw this name in the TOML, and then its type, which its type is a structure. These names can be whatever you want to call them, and then that structure can be have hierarchy to it. So here, some service uses another structure. So you get this what we call structured custom configuration with typed values. All right. So going back to the main. So to get that data loaded, so the SDK loads up all the other configuration on Bootstrap, but it doesn't know that you've added that other section in there. And that's just what's nice about the TOML parser, is if it sees a section that doesn't have a matching name and a structure, it just ignores it. So the SDK's loading of its configuration ignores your custom section. So now you got to tell the SDK, oh, go load this section I've added. And then in that loading, ignores everything else in the TOML except for this section you specified. So it's going to load that section and everything that's hierarchically underneath it. Okay, then you should most of the time make sure your configuration is valid. So I created this sample validation. Some values should be greater than 0. You can throw an error if it's not, that kind of thing. Then if you want to dynamically see changes to your configuration when you're using console, you can tell it to listen on that section or a subsection. So you just give it a reference to the section. So I could change this to some service. And since that's the name we use in there, now it's just going to listen only to the some service subsection of our custom. So I'll only get notified when parts of that have changed. Okay, and the important part here is you got to have this callback function that is processing those changes. And we'll jump to that real quick. Okay, so it's based on that you're doing the app custom, not service. So it's going to cast the raw data that it was sent into what I've called updated here. You get your previous for that data before you copy the updated over it, so that then you can then walk through and check specific parts of your configuration that if they change, you need to take action on. Okay, and here it's a contrived example. So we're just logging out, hey, this one changed, that one changed. But there are many cases where you have configuration in your custom section that you need to take action on. You can't just change some port number your service is scanning for something, and expect it to just all of a sudden change. You got to probably tell the portion of your software, hey, use this port number now, that kind of information. All right, so backing up here. All right, so once you've loaded your configuration, now you're ready to move on to your function pipelines. I'll jump back to the presentation here. So custom function, there's questions you need to be answered about what your new pipeline functions need to do. One is, what data do they need to process? Do they need to process the EdgeX event initially and do some transformation on it? Or are you going to run some of the canned functions first that transform it to something, and then you're going to process it from there? What order do the function pipelines that you're creating or using from the SDK need to execute in? Is there more? Do you need more than one functions pipeline? Do you want this application service to be processing data from multiple devices, and you need a pipeline to process each one differently? So Intel did a use case. We called it real-time sensor fusion for loss detection at checkout. So automated checkout, and so we had the standard weight scale. We had cameras, we had RFID, and of course we had the payment system scanning. We're getting 4 different devices sending data in. At that time, we didn't have this multiple pipeline. And so we had this one function that had to be able to handle all that data and try and reconcile it. With the multiple pipelines, it would have been really nice because we could have split that processing up a little cleaner to handle the different devices in their own function pipeline, and then join the data at the end of that. So very useful for certain use cases. Okay, so let's go back and look at the template, which has some functions, some contrived functions in it to handle the data. So these are nice templates for creating your own function, because you want to be able to do a lot of the same things. For debug, you want to print out a log message that, hey, your function got called. Okay, because you may have filtering of data that's from the SDK set in the functions pipeline before it, and you're wondering why your function pipeline's not getting called. And so this at least lets you know when it's getting called. And then, well, of course, this should never happen, but good error case handling. Make sure if the data came in and it got put in behind a function that didn't pass data forward, then it would error out properly. And then you're checking. This is really important. You always check to make sure the data that you receive when this function is called is the data that you expect. So this function expects the EdgeX event to be processed. Okay, it's a simple function. It's just going to log the details of the event. So now it has the event, and it's just going to do a log statement based on the type. If it's binary, it's not going to. We don't print out the full binary value in the log file, because that would be really bad. But we just print out the length. If it's a simple type, then we print out the type and the value. Pretty simple. And this is important right here. Is this tells the SDK, once it's executed this function, true means to continue executing the next function, and to pass the next function this data. Okay. You'll see up here when we had an error, we said false. It said, hey, I'm terminating the execution and I'm passing an error. The SDK sees that second parameter is an error and will log it as an error. You don't need to log your errors yourself. It will log it when you return it. Okay. Then, so this data, this event, gets sent to the next function. And then in this case, we're planning to have the convert event to transform it to XML. All right. So same start off here making sure we have the data the way we expect it, and we get the logging client in a convenience variable. Then here we call the toXML an event. So event type has a function to convert it to XML already. So we don't have to go through the work. It's there for us. And then, but it could error out. So you handle your errors. And then we're going to just print out the XML in debug. So we always run all the EdgeX service at log level info. And then you have to turn on debug. So log level info will do info messages, warnings, and errors. Okay. And then if you turn on debug, it does debug, info, warnings, and errors. But by default, you want an info so you're not spamming your log files. Okay, here we're going to, this is new in Kamakura. We have one thing I missed, let me back up here, is it's always good to create a structure to hold whatever your functions are working on and have a factory function for them. You'll see us use this factory function later. And here we have this new capability to collect metrics in EdgeX services. And the SDK supports this for app services. SDK collects some itself, but you can also have custom metrics. And so I created a contrived counter for how many events we've converted to XML. And so that's what we're doing here, is we're looking to see, hey, did I create that metric container? Okay, if it's nil, I haven't created it yet, so I'm going to create it. I'm going to register it with the metrics manager that I get from the SDK context here. And then I increment that counter. So the next time I come through here, I've already created it, and I just keep incrementing it. And then this, okay, well, I want to continue executing the next function, but I'm going to pass it XML. And then this function, did we log? Yeah, in debug, we're logging this out. And this function is just going to output the XML. So same basic pattern here. Check to make sure the data is right. In this case, we're looking for a string. We're expecting the data to be our XML string. We're going to output the following to XML again. But here's the important part here. This is what sets the response from our functions pipeline back to whatever triggered it. In this case, we're talking about the message bus. So this will publish this XML back to the message bus now that the pipeline is done. So the last function in your pipeline should return false and nil. Okay, saying the execution is done and it's time to terminate execution of the pipeline. There's no more functions. I mean, if you put a function in your pipeline after this one, it won't get executed because this one said it's done. And if any of your functions have called the set response data, that data will be used as a response to the trigger. If the trigger is the message bus, it will publish that data back to the message bus. And you'll see we have an HTTP trigger that I'm going to demonstrate. It will publish it back as a response to the HTTP request that triggered the pipeline. So now that we have a set of functions that we can use in our pipeline, we need to set up our pipeline. So here is where we do that. We create, use our new factory function to create our container for our functions. And sometimes you may need to pass configuration so that if you've got something that it needs based on configuration, you would pass it to your factory function. So all the functions then have that data to work on. We're going to set the default functions pipeline. This is one that gets processes any data that comes in on the trigger. So if it's a message bus trigger, anything that comes off the message bus, anything that comes off HTTP trigger comes through this. So we're just listing out the functions we want to execute. So we're going to use the built-in filter for device names. So we're going to use that configuration that we had in app settings. That's the list of device names we care about. And it's going to filter the data for those first. And those device names are from our device virtual reference device service that just randomly creates data. And so that's where those device names are from. And then we're going to call each of our custom functions that we created there after we filter for those particular devices. But you can put, depending on what you want to do, you can plug in other built-in functions and you point in here, as long as the data those functions are expecting are being returned from the function before it. And you don't, so if I put anything after this output one, remember it returned false and nil, meaning terminate. Anything I put after this will not get executed. All right. Then as I talked earlier, we have this new capability in the last couple of releases where we can have additional function pipelines based on topics. All right. So now I'm showing the demonstration of how to add an additional one beyond the default. I could skip the default and only have them based on topics. Okay, so this function pipeline, I'm just giving it a random name here as the ID. No, I'm having it, and then the topic is when I get the data from the float device. So this is similar to the filtering, and actually in this template, I should have skipped this filtering because this isn't going to help anything. Then, so basically what this is filtering by subscription rather than filtering by the data itself, allowing me to only run this pipeline when the data comes from the float device. So, so a little extra filtering that really wasn't needed, and then run the same function pipelines. And then this is a similar example, but it only runs on int32s. So that's an example of how to create additional pipelines for topic. The big thing to note, this only works with messaging protocols. So we've got the EdgeX message bus that has topics, and then we got an external MQTT trigger, which of course has topics. It works with those two. HTTP doesn't have topics, so the only pipeline it's going to run is the default pipeline. All right. All right, back to the presentation. Okay, so we've gotten through the data. We've defined our pipeline functions and the function and created our custom functions, defined how they're going to run in the pipeline function or functions. And then we've already kind of hit this, is we've decided whether we want the data to be published back or returned to the trigger. And we return data to the trigger by using the set response data and set response content type context function. So the application service functions have a context that's passed to them that has this API for you. There is a more advanced way to publish data back, and this is specifically for message bus triggers, is a background publisher. So you could have your functions providing data to a background thread. So they process the data, get it manipulated, and then send it on a channel to a background thread. And it's collecting them and doing more analysis. That takes more time, so you don't want to do it in the standard functions pipeline. And then that, when it sees that it's got data in a place that it wants, it can then use this background publisher to send that data to the EdgeX message bus. So I put the links here for documentation on background publishing, because we're not going to get into the details. And then also we converted our app RFID LLRP inventory service to use this. So I put the link to the PR, so you can see how we transformed that to use the background publisher. All right. So the next thing you got to do once you've got your pipeline set up and ready to run is you want to be able to test it with data. So there's multiple ways. So the device virtual is great because it's constantly pumping data to the EdgeX message bus. And you can see that the sample was designed around catching that data. So you can use that, but it puts out a lot of data. And when you run in debug, the SDK is very verbose. So, but I'm going to demonstrate that first. So I've built already. Just a note to you that I've got the EdgeX non-secure stack running. So we don't have any of the security services running. And we've got device virtual right here running. Okay, that allows us to run our service. So I built, so now I should be able to say .app talk and just run it like that, no parameters. Okay, I'm not going to connect up the console for configuration, so I'm just going to use static configuration. I'm not going to connect up to console for registration, service registration. Those are all advanced topics beyond what we're going to hit today. But most services do that. But today we're just going to use the static TOML file. All right, so what you're seeing here is we're waiting for data now. Now we're starting to pump through data, and you can see we've printed out our XML there. And you can see it's very verbose, okay? Device virtual is throwing a lot of data at us right now. So that may be, you know, if I'm trying to test this and seeing it, that may be a little too much, right? It may not give me enough time, or it's hard to get through all this data. So maybe I don't want device virtual providing the data. So I'm going to go over here and disable device virtual, tell them to stop that container. I am going to stop the service here. And I'm going to clear my terminal here. Let's go ahead a little bit bigger and do clear again. And then I'm going to restart him. And now you can see he's just going to sit here waiting. Okay, so let's see here, the presentation here. Okay, so now we're going to pick a different device service. So device rest is part of our standard services that are running, but it only sends data in when something's posted to it. So we're going to take advantage of that device service already running, but we're going to use Postman to provide the data to it. So device rest will take, it's got a few reference devices. I'm using the sample numeric reference device, and it's got an int resource. So basically anything I post to that resource needs to be an integer. If I post a string, it's going to fail because it can't parse it to an integer, and it will take that value and put it on the message bus. So what you're seeing here is this sample service has the metrics enabled, and it's collecting the built-in metrics that and our one custom metric. I'm going to disable that real quick. Going into the TOML file, go up to our metrics section. And it's in, I could have done it, well, if I was running with console, I could have changed that in console and it would have stopped it. So setting the interval for reporting to 0 disables it. So now when we start, we won't see those log messages. All right, so back to here, and I want to do this so we can see what data we get when we post. So we're going to send this integer to the device rest and watch it get now received here. So now you see this is all the data we received in debug, because I have the environment variable setting log level to debug, exported in my terminal so that anything I run from command line is always running in debug. So you can see, hey, it found one pipeline matching the topic and it's sending it to it. You can see all these messages and didn't accept it though, because it doesn't know this device. Okay, let's go fix that. So the filtering we put in there was for other devices, right? So let's go all the way back down to here. We have our names here. So we're just going to add a comma here, put that name numeric in there. This is not in writable, so I have to rerun, and I'm not even running in with console. So I have to do that. So now, again, let's put some spaces so we can see what happens. I'm going to post this to the device rest. I get my data, and now you can see, because we have XML being printed out, it did process that because it recognized that device in the filter now. So that's one way to just minimize what data you're getting to your service. You can use device rest, but device rest has some just basic, simple, contrived profiles and devices, similar to kind of what device virtual does. It doesn't give you any real data. So if you've got data, event data that you expect to be getting from a device service, but you want to just isolate and run the app service by itself and not need EdgeX running. So what we're going to do here is we are going to jump over to my terminal, and I'm going to just shut down EdgeX. So the HTTP trigger really is only use is for this development. Okay, so I've shut down. So if I go back over to Portainer and refresh, I don't have any EdgeX services running. So now I'm going to go into the trigger configuration and just make one little change here, because the rest of this configuration will be ignored. I've changed the type to HTTP. So now it's going to expect to get data off an HTTP endpoint. We're going to put that here. Oh, connection refused. So it's going out to try and talk to EdgeX still. So that makes it hard to run if we just shut down EdgeX. So we're going to tell it to skip a version check, but it's still going to have trouble, I think. Oh, nope, it didn't. Okay. If we had registration turned on, it would, of course, have issues because EdgeX is not there for it to register. So now you can see that its HTTP trigger is initialized. This allows you to send data to it using the trigger endpoint directly to your service. And then since our service, our default pipeline is expecting an event, you can post the event in any data that you want. So if you just adhere to the EdgeX event JSON structure, events and readings, you can pass in data that you like to see it process. So I'm going to run here. I'm going to now send it to the trigger. And what's neat is this shows an example of our XML being posted back as a response to what triggered it. In this case, it's the HTTP response. So we got this XML data back from that function's pipeline because we said set output data and gave it the XML. Then also you'll see the same debug logging in the log file here that we had previously for processing. For debugging, I'll leave you, for everybody has their favorite editor for debugging, but this allows you, I could run this in the debugger, set breakpoints, trigger it this way, walk through my code. Real simple. I don't need EdgeX running right now. as long as I've got the EdgeX event JSON that works with my functions, and I can see what they're doing and verify, maybe debug an issue that I'm having this way. All right. So those are the ways you can test your, your service in different ways. I like using device virtual to smoke test things. I bring up I've done changes. I want to smoke test it. I want to just see that data is flowing properly, that I'm getting data off the message bus. And then I'll use the trigger, HTTP trigger, if I'm doing something more specific and I have custom data that's coming in. There is the ability to process non-event data off the message bus. It's a more advanced topic. It's called setting the trigger type. So if I had a different object, different JSON structure, I can do that also. I encourage you to browse the documentation. So here is the app services documentation. Well, the note here is that for every release, we increment the version for the documentation. So this is a link to the Kamakura 2.2 documentation that we just released. There are a bunch of examples for EdgeX app services at this link. Some good transformation examples, like one that transforms EdgeX events to InfluxDB formatted, so you can send the data to InfluxDB, and depending on what your events are, you could then graph them in Grafana doing that. Other references we have here, we have a Slack organization. Good place to go in and ask questions. There's lots of channels. But use the appropriate channel. So if you have a specific app services question, use the applications channel. But if you don't really know where your question best fits, use the general channel. As I had mentioned in a comment, the EdgeX YouTube channel, all these presentations are being posted there. The code for all of EdgeX is in GitHub at EdgeX Foundry. And we have these other social media resources here. So we do, just want to reminder, next week is how to build a custom device service for EdgeX. So we just talked about processing on the north end. This is about getting the data in from the south end, from your devices. And we have a few minutes for Q&A. If anybody has a question, you can raise your hand or post it in the chat.
Lenny, we've been trying to tackle questions as they come in as well on the Q&A, but for those online, as Lenny mentioned, either type them into the chat window or the Q&A window.
Oh, is there a Q&A window separate?
There is, yep. And I've been tackling those questions as they came in, so I think we're good.
Thanks, Jim.
No problem.
I was looking for the chat window for the questions. A newbie at doing these tech talks.
No, you did great. And thanks, Lenny. And thanks for everybody for attending. As Lenny mentioned, please stay tuned to both the YouTube channel and the wiki site, which I put a link in the chat for if you want to get the recording and or the slides for today's session.
All right.
Lenny, I think that's all the questions we have. So thank you, Lenny, for presenting, and thanks everybody for attending today.
All right. Thanks all. Talk to you later. Bye.